All right.
Okay. Well, thanks for setting this up, Nick, and thanks for everyone who is attending here today. So our topic for the meetup is Nick, I'm getting some feedback.
How's that? Did we
That's
kill
better.
that?
That's
Okay.
better. Thanks. Okay. Okay. So our topic today is intro to network telemetry using Apache Kafka in Confluent Cloud. I'm still getting the feedback.
Do you have the YouTube link open by chance?
No, I don't think so.
The only ones unmuted are you and Nick.
All right, let me try it again here. I killed that browser, so let me try to share here again. I think are we good now? I believe so.
Yep.
Okay, sorry about that. That was an inadvertent thing. So just a little background abstract for reference. This concept of using Apache Kafka is something that I've worked on a couple of years back now. We'll go through a little history of that. More recently, maybe about 2 years ago, I first discovered Confluent Cloud, which provides a managed software as a service for Kafka. And one of the nice things about that is it gives you the ability to very quickly and as a trial standpoint, be able to spin up a Kafka instance that you can do some experimentation with. And it seems like this year, the whole concept of AIOps and machine learning is becoming more and more pervasive in the network industry. So we're going to talk about an introduction. We're going to talk really primarily about how easy it is to get started with message bus, in this case, Apache Kafka. So just a little bit of background on me. Joel King, distinguished engineer at Netcraftsmen, and I've worked on a variety of things years past. Spoke at Ansible Fest, have done some work with Pensando, and also a lot with security policy around Splunk Phantom. So we try to keep this as interactive as possible. Anybody have any questions, please feel to interrupt. The meetup's all about getting people to talk and to engage with these particular topics and to add your own viewpoint as well. So I have some examples. We have a sample repository, code name Semaphore, and also a repository from some of the work that I did a few years back now with Tetration, which also runs for the network policy publisher a Kafka instance there as well. And interestingly enough, both of those are Python based. In the case of Tetration, I used a different Kafka library for the reason that our Tetration instance that we had at the time had a self-signed certificate, and I was not able to use the Confluent Kafka library because it didn't allow you to provide your own SSL context to use your own certificates. So the code examples that I have, and I have published both on GitHub and on GitLab, show two different Python libraries for interacting with Kafka. In the case of Tetration, they use protocol buffers from Google to be able to serialize the data that's being sent in the Kafka messages. And in the example that I have in the Semaphore repository, it's using Python as well, and then we're just putting some JSON data that's in a byte or bit string to be able to generate messages for Kafka. So there's two good examples here. The protocol buffs is a bit more involved, which we'll see and talk about that. Just the learning curve of being able to do that is more involved than the simple example that I have with the semaphore repository here as well. And for those of you not familiar with it, Nick is live streaming this meetup on YouTube, so people can watch the live stream, but you can also go to the YouTube channel and look at the replay there as well. So agenda, we're going to just talk about some Kafka architecture, some terms, components, give you a little historical context about what I've worked on in the past with Tetration and the Kafka server there. Quick intro to Confluent Cloud to show you how easy it is to set that up. And we'll look at some sample code, a little bit of a demonstration. And then just looking forward, what can you do with this? What's the next step? And Nick's going to talk a little bit. We'll save some time for him at the end because he's going to talk a little bit around some of the things that he's interested in and working on as well. So with that, we'll get started with the architecture terms and component. One of the good things about Kafka is there is a tremendous amount of online information. So it's very popular from a software development standpoint for microservices. Found a lot of info, and this is an example here from Spiceworks blog. What is Kafka? It's popular because it has very low overhead compared to, say, RabbitMQ, and I've not worked with RabbitMQ, so if anyone has, that might be a good topic in the future. And one of the reasons why it has low overhead is it doesn't really do much in terms of management from the user standpoint. It doesn't remove messages that have been read. It keeps the messages in the Kafka message bus for some period of time. I think and the defaults kind of vary depending on the implementation, but I think like 7 days is one of the defaults that you've seen, and it's really up to the user to track what's been read. Each node in a cluster, and you could have one or more brokers within a cluster depending on the implementation, and they can operate on multiple servers, or in the case of what we're looking at with Confluent Cloud, that's going to be a software as a service, and we just don't have to care about the implementation of it. So Kafka has the ability to really scale, has the ability to generate a lot of messages from different publishers and multiple consumers. So it's very lightweight from the client standpoint. And it's also fairly easy from the publisher standpoint to publish messages as well. So it's just some of the terms. We just have a couple of slides of terminology. We talked about clusters, and that's one or more servers, each of which is called a broker. And I say by default, they listen on TCP connect port 9092, but I realized looking back at the information from Tetration, they actually listen on port 443, so the port doesn't matter. But when you subscribe or when you get the credentials for a Kafka cluster, it'll tell you, what the IP address of the brokers are, or a host name of the brokers, and what port to listen to. Topics are another important aspect. Topics are an ordered log of records or messages. So sometimes I'll say records or messages, kind of use that interchangeably. I guess it depends on your perspective, but this is where you define a topic, and then when you want to publish messages, you publish them to a topic, and they're simply appended to the end of it. Partitions are within a topic. So when you configure this, and we'll see it in Confluent Cloud, you'll get a default number of partitions, and this is where the scalability comes into it. So each partition is a single log file where these records or messages are written to in an append-only manner. And we'll see how, from a publisher standpoint, how you can influence what partition is being used at any point in time. What you actually publish in this message bus is a message that consists of a key value pair. And we'll see that the key determines the partition of the topic. And I have some examples of that. And then the values are just simply byte strings. So I said in the tetration use case, that was a protocol buffer. In the case of the semaphore repository that I have, it's just simply a string, and that string is JSON data. And the max size is configurable. In Confluent Cloud, a lot of the documentation will say 1 meg per message, but Confluent Cloud, when I was looking at it over the weekend here, they use a value of 2 megabytes as being the max size on it. So that ties into, and we'll see how that can be somewhat problematic, I think, if you have very large messages. So one of the key points about all of this is that message key. So when a publisher publishes a message, it provides the key, and that key determines what partition they're written to, and it is a guarantee on ordering at the partition level. And I have a slide to kind of show how that works. And we talked about log retention. So messages aren't discarded when they're read. So the Kafka cluster doesn't keep track of that. But when that log retention expires, that's when they're deleted. So it's very lightweight from the standpoint of the publisher and the consumer. There's not a lot for the Kafka brokers to keep track of, so that's why it can scale very well as well. So we'll say, from a terminology, a publisher or a producer, and sometimes you'll see those terms used interchangeably. Essentially, they're the ones that write data into one or more, into a broker, and they'll specify essentially the name of the topic and a key value pair, and that's all that they have to do. So the Python library, to be able to do that's fairly lightweight. It's fairly easy to publish or consume. In that case, a consumer reads messages via a TCP connection to that broker, and they specify the topic that they want to read from and what their consumer ID is. So you could have multiple consumers, and they can specify that same consumer ID. So there again, you can have scalability from a client standpoint. The other two important terms are offsets, an offset and a consumer offset. So an offset, essentially, it's a zero relative integer value that identifies the order of the messages, and we'll see an example of this. And then the consumer offset is something that is maintained by Kafka, and that's basically a bookmark. So if a consumer would crash, or in our example here is I don't have the consumer or the publisher running all of the time. The consumers know where they can start reading where they left off. You'll also see, from a terminology standpoint, the concept of a zookeeper. We don't have to get involved with that, really. Confluent Cloud takes care of that, but just you'll see that term. Zookeeper is there for management of the cluster. It does things like provide, from a scalability standpoint, it manages the leader of the partition. So if you have multiple brokers within a partition, they'll actually, one of those will be a leader for that partition. And it's also from a high availability standpoint, there are subordinate brokers that manage other partitions and make copies of partitions as well. But you'll see Zookeeper, but we don't, from a publisher or consumer standpoint, we don't really have to concern ourselves with too much about that. So from a historical standpoint, I started working with Kafka via Tetration, which is now called Cisco Secure Workload, and actually did a number of blogs, did a number of presentations at Ansible Fest. So there's a whole lot of information out there that you can take a look at. The repository for the Tetration use case has a number of links. But this is just one example of where a message bus would be important in terms of tetration. Well, the aspect of tetration is that they're publishing policy, security policy, to their message bus, And here's a little snippet code example of what you might see. So tetration is about understanding what workloads are in a particular data center, and it would publish to Kafka so that other applications could take that same policy that's being pushed down to the enforcement agents on the clients. In this case, it would be Windows or Unix servers, Linux servers within a data center, so that they could do enforcement through their IP tables. But they also publish this policy to the Kafka message bus so that other applications could use it. And that was what my interface was with it. So in this example, you see a VRF, in this case, a tenant name of pub VRF, and then a list of intents, and these intents being ports, start and end ports, protocols, and whether you are allowing it or denying it. The filters and the intent IDs are all keyed toward information that's within Tetration that's available via the API. And we'll see, as an example, this policy publisher would publish this policy. My interface to it was writing an Ansible module. This is prior to Ansible collections. We just wrote modules back then. But the whole idea behind the policy publisher was it would send an alert. So we were operating from the standpoint of the consumer or the client. The infrastructure within Tetration implemented the broker and also the publisher. So my use case was an Ansible module that would connect to that Kafka broker, subscribe to that specific network policy publisher, sit there and wait a minute or two. Sometimes the timing is important, and then retrieve those policies that are published on that message bus and then apply those to other places in the network. So it could be ACI, it could be a firewall, could be a load balancer in the case of a firewall combination load balancer in the case of F5, could be something as simple as a firewall. So that was how I got started with it back around 2018. It's probably a little bit more complicated than what it would need to be for someone that's just getting started with understanding how to use message buses. One of the reasons why that was more complicated, and at the time I had no experience with either protocol buffers or Kafka, so I was starting at a disadvantage. But in that example, because of the sheer size of these messages, you would see these protocol buffers that they could span one or more messages in Kafka. So in the use case here, in the example is the way it was implemented, they would have an update start header, they would have multiple updates, and they would have a message that was an update end that was only 8 bytes, but said that you're done with it. So why this was even more complex than what most use cases would be is the fact that you had multiple Kafka messages that made up one specific policy. So you also had to iterate through the messages and find an update start, decode it if there was more than one update, and then take that protocol buffer and essentially pull the information out of the Google protocol buffer and write it out as JSON to the playbook. And this is just an example of that. So this is Ansible Playbook. It's in the Git repository. It shows the use of that Ansible module that interfaces with Tetration's Kafka. And you can very simply write that policy out to a file or take that policy and put that into other aspects of that Ansible Playbook. So that was how I got started with all of this. And then probably maybe 2 years ago, Tim Hall was working with, I was helping him out with a project, and he had a financial customer who was interested in publishing to Kafka. And I found Confluent Cloud. And what Confluent Cloud is essentially software as a service. They do a managed Kafka implementation. It's real easy to set up. We're just going to drive through some of those slides to show you how easy that is. A free trial, uses a free trial, and they have a tremendous amount of knowledge transfer, blogs, examples, so on and so forth. They have a Python package, Confluent Kafka, which we'll use in the demo here today. They also have a Terraform provider. So it's an easy way to get started. So you can sign in with GitHub, Google, or create an account. And we'll just walk through a couple of slides just to talk about how easy it is. But you start by adding a cluster. So that's the first step. You get a free trial. You can use this without putting in a credit card. And for the demo, I've got another 4 days, I think, on the free trial. But it's easy to get started. You basically set up a free cluster. They have some limits on the amount of storage, the number of client connections, the number of partitions, and so on. But it's easy to get started with Confluent Cloud. You actually, when you create a cluster, you can pick one of the cloud providers, and they'll actually spin up an instance in that cloud environment that houses your cluster. And again, it doesn't cost you anything for the trial. So they're actually consuming some resources in a cloud provider, but you create your cluster, and then they'll ask you to create a topic. And we said that topics were, you can have one or more topics within a cluster. In this case, we just take the default values. We launch that cluster, and as part of launching that cluster and then the topic underneath it, we get the option of being able to create a number of partitions. And I said the default was 6, so we select 6. And within a few minutes of using Confluent Cloud, the only thing that you need to do is, in this case, is create a key and download it, and it'll get downloaded as a file. And you see an example here in Notepad where they'll give us an API key, an API secret, and then the Bootstrap server. So they'll give you a host name, and in this case, port 9092, and you're up and ready to go. So in the code examples, I use environment variables to pass those into our example. And it's pretty much as simple as that to be able to create a Kafka cluster, a topic, and then have access to it through an API key. So any questions before we kind of look at some demo slides here and move on? Has anyone used Confluent Cloud before? Or used Kafka in a container, which is what Nick's going to talk about. Okay.
I've used Confluent Cloud before, and the one thing I would tell everybody, at least from my experience, is don't sign up for their marketing emails, because they like to spam your mailbox. At least that's been my experience. So yeah, turn that off.
Yeah, I think that's an option, right? You can say you want to opt out of that. One of the things when I work with it, helping Tim out, they actually assigned me a person to talk to, a technical resource. Did they do that with you, Tyler?
I think they did, but I ignored their emails, unfortunately. But I will say it is a cool solution. It's very easy to set up and very easy to use. It's a nice managed service. So nothing against the product. I just know I got a bunch of emails from them once I signed up.
And that's becoming more and more of an issue for anything that you sign up with. So you can't lay the blame solely on them, but it seems like anything that you sign up with that you're going to get some emails on. So, but I found that, Tyler, you can tell me what you thought of it, but I found that their blogs and their documentation that it's really good. They do a lot to help you use their service. Was my takeaway.
And I think that's how I found them initially. Is I was trying to learn more about Kafka at the time, and it probably started a couple of years ago. But to your point, they have a ton of great blog resources to help get you started and get a better understanding of how the solution works. So yeah, I would agree.
Okay.
Joel, I'm just wondering, so I was playing around with Kafka last week, actually, like in a container. And when you start Googling around, Confluent comes up like pretty easily. Are there any other SaaS like Kafka brokers out there that you're aware of?
The only two that I've worked with is the Tetration implementation and Confluent Cloud. And Nick, before we started recording, Nick said he's been playing around with spinning it up in a container.
Yeah, that's
And that might be a good follow-on session.
I was joking with Nick over chat, but so the different cloud providers also have managed Kafka services. So like AWS has MKS,
Yeah.
that allows you to set up a like managed Kafka cluster. I've never worked with it, but if it's similar to the other managed services, it's probably easy to use and set up.
Yeah, so that's it's pretty pervasive, and the other thing that you'll find is there's a lot of things on Stack Overflow. People have questions. I found a lot of resources out there. There's a lot of people that have blogged about it, which obviously I started the presentation off with a link to a blog. So I found a lot of very valuable, useful information on how to use it. Is been my impression. So how I got started on all of this semaphore code name repository, I started this a couple of years ago from the standpoint of I wanted to generate some telemetry data off of a network device to be able to experiment with Telegraph, Influx, TIG server, Grafana. And I started with that and then never really kind of completed it. But I had some basic telemetry data. So I have a Meraki instance here at my house and have this Meraki gear for quite a while. And I said, well, what could we do with it? So anytime I want to tinker around with an API, I tend to gravitate back to Meraki. Meraki has an API to be able to retrieve your uplink loss and latency. So I set my Meraki configuration up to test connectivity to Google's DNS 8.8.8.8. And you'll see that we can, if you want to generate some data, and there's probably other ways that you could do this as well, but since I have the Meraki gear available, that was what I started to generate data from, and have a couple of programs in this repository. One as a publisher, that's the latency Lawson logging. So that is retrieving info from the Meraki API, and it outputs Syslog, which is what I originally started with because I wanted to have some Syslog data so that I could take into Telegraph and Influx and look at it there, but I never kind of completed it. So over the break, I said, well, I'll start with that. We already have Syslog data, and I'll take the work that I did with Tim a couple of years back and put that in the same repository and prettied it up a little bit. So essentially I have a program out here that has a switch on it that will generate output to either Syslog, to Kafka, or to both of them. And the reason now is we can kind of compare and contrast data going to Syslog with what would go into a message bus with Confluent. And then I used some of their example code to put together a quick consumer, and the consumer essentially, both the publisher and the consumer just output some samples, and I have some debug options where you can be a little bit more verbose, but you're certainly welcome to look at that. So there's two programs. They both share the same Python constants file. And as I said earlier, I use environment variables to pass these in, and they're running in a container, so they might still be active over here. And yes, so I have a container set up that's can produce records, and I have a container set up that can consume records. So that's what we're going to look at. Run the program, put the help in. The Meraki API, you set an environment variable to pass your dashboard API key in, and send a switch into it that we can publish some data with. And let me just do that. We have some slides to do it, but we'll go out and do both. And let's see what happens here. So it has to connect up to the Meraki cloud, pull the data out. There it's actually generating some Syslog data. And it also produced two messages, two records to the topic, the partition, the offset, and then the value. So that's just for some debugging information. So that's, that is that little piece of code. That's about as simple as it gets in terms of showing you the data that you would normally see in a syslog. So we have the server, the port that we're sending it to, and then this output of the JSON that is going to syslog, and then that same key value pair. Remember, I said everything is a key value pair. It is being generated and sent to Kafka, and I just truncate the start of that. So that's the publisher or producer piece of it. And the thing that you want to, just for reference here to look at, is that the output that I generate says that I generated at the topic _0, which is what I set up in the dashboard Confluent Cloud. It went to partition 1. It was at offset 27 and 28. The key was candy bars, and the value was essentially that latency and logging output that came from the Meraki cloud. And we'll see how those keys influences. So we set the values that we set programmatically are the topic that we're writing to. The partition is derived. The offset is managed by the Kafka implementation. We can influence the partition. We'll see that in a second. So we have a key and a value. In the case of the Tetration implementation, they always wrote to the same partition because they always used the same key. And if memory serves me, it was a numeric value of 2, which doesn't have much meaning, but that's what they used. And then the consumer piece of it, a few more options on the consumer, and most of them we take the defaults. So we have this group ID. I only have one consumer, so it uses the same group ID. We're going to look at the latest messages, so we're going to read from the end of it. I have a timeout value for polling, a range, and then a verbosity option. So if I look at this consumer, and the ranges is how long I'm going to look at it, and verbosity is just going to output some data. So those messages that I just produced with the on the left-hand side, what we just looked at, I'm consuming using this Python code running in this container that's in DigitalOcean. So I have, just for context here, I have a DigitalOcean droplet with these two, with Ubuntu, that has Docker installed, that has 2 containers. And the code that we're consuming is just over here. So it is just a rather concise little snippet of code. So it is essentially, we import the consumer, we subscribe to the topic that we've passed in the arguments, and we go out and we poll. We just use this consumer poll to be able to poll for messages, and we sit there and wait until a message or we get an error out of it, and then simply output that. So this JSON output that you see here is the output of that message. So it is that same data that was logged via syslog also is being consumed by this particular consumer. So any questions there before we really go on? And that's just the output which you saw. consumer offset is like a bookmark. So because Kafka kept track of that for me, it knew that I had already consumed other records. In this case, we retrieved offset 26 and 27, and I'm just outputting the topic, partition, and key. Any questions there? Credentials, just for reference, you can set those yourself, and these credentials aren't the current ones, so copy and paste on them probably won't do you much good, or at least I hope not. And then the relationship to the partition, I put an example here where from a programmatic standpoint, I'm changing the key. So I'm using different candy bars here in the case of a Zagnut, Snickers, and a peppermint. And you'll notice that as we, in this example, as we change that key, the partition it writes to is different or is the same. And that all goes back to how Kafka works. It hashes that record key depending on the number of partitions that you've configured. And what that hash ends up with, those keys will be written to different partitions based on the key. So in the case of Zagnut and Peppermint, they were both written to partition 1, and you'll notice that up here we wrote to Zagnut and we had offset 0. Whoops, I'm sorry, offset 0 and 1. Then I changed the key, ran the program again, it went to partition 2. We had already written some to that partition, so it was offset 17 and 18. I changed the key again, and it came back and hashed to coincidentally just hashed to partition 1, so it wrote offset 2. So the only thing you really need to be aware of, it's kind of a cultural side, but the fact that if you want to guarantee the order of messages, you're going to want to use the same key, because that key is going to determine what partition it writes to, and the only thing that provides the sequencing of that is the partition. So depending on what your use case is, probably want to use a key for certain use case. In the case of like a business transaction, it might be like a user ID or a customer ID or something of that nature if you want those in a particular guaranteed order. And then this is just an example from the consumer side. So the order is only guaranteed within the partition. I said the message key is hashed to determine that assignment. And then you'll see I color coded these so that from a consumer standpoint, I am reading from the same topic, and the data that the messages that I return, because I controlled it from the publisher side, the order of those is really determined by that publisher, and I have access to what the key and value are, but I can't control what partition it is. So that's just one thing that you control from a publisher and you need to be aware of from a consumer standpoint. And then just sort of in the interest of time, some things that we didn't cover that I thought was interesting with the Confluent Cloud is they have this thing called a Schema Registry, which I haven't implemented here because obviously this is sort of an intro, but they have the ability to govern what the data should look like. So as data in, garbage out, Schema Registry is a way that you can make sure that the data that is being published and consumed is valid data, that it isn't incorrect data. And I learned that I think it's MongoDB has the same concept, where they have this concept of a schema contract or a schema registry. So that would be more important, I think, if we have application data as well. And then just some use cases. So article here, again, this was a webinar by Confluent. Interesting about from a telco standpoint, where the telecom industry might use Apache Kafka and Confluent. Normalization of multiple telemetry schemes. So if you have data coming in from different telemetry streams, you want to input that data or read that data, reformat it, and then generate it and publish it on a message bus. Now you could write some code to be able to normalize that so that you have a common schema that make it easier for your consumers to consume it. Call detail reporting, many years ago, back in the telephony days, that was an application that I wrote to manage call detail records, and essentially that is your billing. We don't pay for phone calls pretty much anymore, but telco use case of being able to do call detail reporting or billing. Different log aggregation and filtering would be a use case. It kind of ties into the telemetry and the AIOps piece. And then Nick is going to talk a little bit here about event-driven automation. I know that Jeff's been working on that as well. So just think about that. That's a new thing from Ansible. The other thing that I thought of too is that we've been doing some work with ServiceNow with different clients. And one of the things that you could do is develop your own mid server. So in ServiceNow has this concept of a mid server. And often in many cases I know that Colby was telling me the other day that he's doing this for a particular client where rather than implement a mid server, they simply write some code to be able to query ServiceNow and pull back information in terms of some configuration data that needs to be done. Well, one use case might be that rather than use ServiceNow's mid server, you write your own. You have a query to ServiceNow, you publish to Kafka events or messages, and then you could potentially pick it up with Ansible or something else in event-driven automation. So one last thing, and then I'll ask Nick to maybe talk about what he's going to be doing next is last week, John Kavanaugh and I were out and it was for lunch, and it was recommended to us that we look at Selector AI. So I watched this earlier in the week. It's on the Tech Field Day, and Selector AI actually both reads from Kafka, but also under the covers uses Kafka in their AIOps application. And it's kind of an interesting twist in terms of being able to troubleshoot network problems using Slack as the preferred user interface. They also have a web page, but they use Slack as a user interface for chat ops into their AI operation. So Nick, why don't you talk a little bit about what you guys are up to?
Yeah, thanks, Joel. I think the thing I really wanted to just highlight is that what you've been talking about today, I think, is a really kind of key component to using automation to kind of close the loop, right? From an operational standpoint going forward. And when we look at what happened at Ansible Fest this last year in October, the announcement of kind of the early developer preview of the event-driven Ansible solution. When you look at how that's built and really the idea around that, right? Think of it as kind of an engine to allow you to do kind of if this then that type of automation based on a message that triggers an action, right? They've defined a bunch of plugins that exist or that they're going to have available, and some of those are integrations to things like Alert Manager and Azure Service Bus and things like that. But one of the first ones that they released was Kafka, and when you I think when you look at the kind of natural state of putting messages on a bus and picking them up, Kafka's been around for a plenty long time now, and I think when you look at rather than integrating to product after product after product and have to do it in some bespoke way to deal with some of those varying tools that might be triggering alerts that you want to act on. Most of these tools that I've seen have some native integration to put a message on a Kafka bus already, right? So being able to start to consume those messages off of a bus and then write playbooks to go remediate something in your environment based on that action, I think is um, really where it's going to, you know, continue to push, I think, from an industry standpoint over the next year, right? They've with that announcement being developer preview, the goal and the hope that that'll go production sometime, later this year in 2023. But I think we'll see an uptick of people being interested in it. Obviously, we're spending time and effort on getting it up and running and understanding how it works, and all of that I think ties directly back into what you've shown here today, Joel, right? Which is, how do I get some state information from my infrastructure, and how do I act on it without having to, either continuously poll and monitor and look at the state of the infrastructure forever from all of the tools that might act on it, but instead collect that information, put it on a common bus, and then deal with it from there. And I think that's going to be really, really impressive over the next year when we start to see how people use this and consume it.
I mean, the use case that I have here with the Meraki is just, I mean, that was just data that I wanted to have some data, to work with. But, if you think about it, I mean, my example here is running in 2 containers that are running on a Linux host or a droplet in DigitalOcean, but you could run your publisher and on, maybe it's like a catalyst switch, right? And using the containers there, or some other place in the network that you want to be close to the data and you want to maybe do some filtering of it, right? So I could have, a good example from the Selector AI webinar is, and I didn't know this, but ServiceNow bills by events. So this actually came up with a client conversation today where they get a lot of events in that are false positives. So if you, rather than generate events directly into ServiceNow, if you would generate events to a message bus, have a program that would read that, filter them, and then republish them on a different message bus, then you could do some pre-filtering so that the integrity of the events that you actually put into ServiceNow are more relevant. That was one of the discussions that we had.
Yeah, and I think even when you look kind of holistically at the type of information that you can get from the network too, right? Who joined an SSID, right? What type of clients are connecting to the network? Monitoring for those, potentially having an action if it's a client that you don't want on the network, whatever it may be. There's a lot of things that get opened up by being able to kind of react to information in near real time, right? And I think that part of it is something that will be really interesting as people start to figure out the types of messages you put on the bus, and to your point, making sure the right messages are on the bus will be an exercise that will probably result in a lot of front end work for people, right? Making sure that you don't just fill it with everything, but um, uh, being able to pick something up and react and respond in that type of environment with no human interaction, I think will be huge.
Well, the other thing too is, and I didn't really touch on this too much, but we kind of talked about it a little bit with Tetration, but the idea being that is it doesn't have to be just one consumer. You could have a number of different applications within your enterprise that was looking at the same data, right? So that's another thing to think about is it's not a one-to-one relationship. That data is there and it could be used by a number of different applications to be able to derive some information about the network state or people joining the network or different events in the network, but it doesn't have to just be one consumer. I mean, you could have multiple consumers with the same group to look at that data.
Definitely. And just looking at the audience and knowing how many people are involved in kind of delivering automation capabilities, you think about just the fact of um, writing automation to deal with messages on a bus. It's kind of a use case generator in and of itself too, right? the more work that, or the more messages on the bus, the more opportunities to deliver value back to the business by automating against those messages and solving some business challenge that may exist because of it as well is really cool too.
Well, and you talked about spinning this up in the Kafka in a container, but the price, even the pricing of the Confluent Cloud, after you get off the free trial, it's, I think, like $1 or so an hour. But you know, if you do the math on that, that's like maybe what, $1,000 a month or something. I mean, not having, being able to experiment and not have to manage that service, that's not like terribly expensive for a large enterprise company to be able to provide that sort of resource. Or, and I don't know, Tyler, how much do they manage Kafka services on that you were using the cloud providers? Do you know what they cost, what their cost is? It's probably less than that.
I'd have to look. I don't know off the top of my head, but it would be pretty easy to find that data. Usually they're pretty good at publishing that information.
What were your use cases? You said you were doing some, what were you looking at?
It's more just experimentation. So I was throwing log data at it and telemetry and just experimentation with it more inside of AWS.
Okay. Any other questions or comments for Nick or myself or anybody else? Observations?
All right. Well, with that, we'll give everybody 5 minutes to get back. I'm sure everybody's got a hectic rest of their day ahead of them, but I want to thank everybody that showed up. Thanks again, Joel, for presenting today. As always, great content. For those that want the recording, obviously we live streamed on YouTube, so that recording will be available pretty much instantly once we end this call. And then I did drop a link to the community on wwt.com, which is where we post the presentations and the links to the repos and a copy of the recording as well. So if you haven't got that bookmark, go ahead and do that as shortly after this call, I'll get the recording uploaded and a copy of the presentation and everything posted there. So with that, thanks everybody. Have a great day, and we'll see you next month.
Thank you. Thanks, everybody.